Hello and good afternoon, everyone, if it is afternoon where you are. Just wanted to hop on real quick and introduce myself. My name is Tanner Dutton. I am our Kinematic LiDAR Salesperson here at RIEGL USA. Just wanted to thank you all for attending today's webinar, Driving Towards Success, Mobile Project Planning and Management. All right, so I'm going to go ahead and get started today. So I just wanted to thank everyone for attending today. Today's webinar should be somewhat short. So we're going over three main things today. Number one is going to be setting targets for Auto Tie Wizard. So if many of you do not know, in RiProcess, our LiDAR processing software, we are able to auto tie our LiDAR cloud to our control points. So today we're going to be going over best practices when actually setting the targets out in the field, and also some conditions we need to think about when we are actually out driving and doing the collect itself. We're also going to be talking about RiMAP, which is our ArcGIS add-on that you can use for project tracking and management. We're going to go over some of the features and some things you can do with the data once you actually get it into ArcMap. And then just kind of at a bonus, at the end, we're actually going to be going over through a new workflow we've created for actually merging our terrestrial data and our mobile data in 5 easy steps in RiProcess. So should be a pretty short agenda today, so I won't take up too much of y'all's time. So kind of starting off, talking a little bit about ground control and our targets. So as many of you probably know, good ground control points and targets is necessary for the utmost accuracy of our point cloud. Of course, if you're trying to get the best accuracy out of a point cloud, you need the most accurate ground control points as possible. That's the only way we're going to get that sub-millimeter accuracy we're looking for. So the identification and linking of those ground control points is actually a very labor-intensive task. And when I talk to most people, you know, when you go in through their actual workflow, processing workflow, that's actually what they spend the most time on. So if you're not taking advantage of RiProcess's Auto Tie Wizard, it can really save you a lot of time in your workflow if you're not auto using it. So the thing with the auto tie objects is, though, you know, there's some conditions we need to look at when you're setting your targets and also when you're driving to ensure when you're actually in post-processing that you're going to be able to actually auto acquire those targets. So real quick, we're going to start off with a quick poll. I'm going to launch it really quick for everyone. But it's just going over quick of, you know, what targets you guys are currently using for your mobile scans. So I'll leave that up real quick. So yeah, if we look at our results, looks like most people are using either checkerboards or chevrons. That kind of goes, I see that quite a bit. A couple people using rectangles and some people using others. So if you are using another kind of target, if you wouldn't mind putting that in the chat, I'm actually curious what you guys are out there using. So that's what we're going to first dive into, is actually what target types are actually supported in RiProcess. So currently in RiProcess, the targets that we can actually auto detect are our rectangles, our checkerboards, our discs, which no one showed they used in the chat, and chevrons. So those are the 4 types that are currently supported. One important thing to note here when looking at our actual shapes is that actual reference point where the ground control point actually is. It is important to note that if you're wanting to use the automatic detection, that your ground control point needs to be placed in that reference point. So you, for example, if you're wanting to use auto detection, you're not going to be able to put the point on the inside of the chevron or on the checkerboard. You're not going to be able to put it on one of the ends. It's going to need to be in the middle. So that's just the first kind of, when you're thinking about the practice, is you're going to want to make sure that you're placing the ground control point on the target in that orientation. So the first thing we need to talk about when we talk about targets is their actual dimensions. So the actual correct dimensions of the targets is crucial for us in RiProcess. If we do not tell RiProcess the correct dimension, it's not going to be able to find it. So I don't know how many of you know this or how many of you use RiProcess and know about this file in the file format, but the control objects types JSON file found here at the 0603 observations, we can actually change the size of the target. So if you're using a different size target than is already defaulted in RiProcess, you can actually come in here and change that default size, save this file out, re-import it into RiProcess, and then it's going to be able to support that target size. So if you, for example, are using a different size target than you see, so that as the default, that can be changed and customized. So that's something to keep in mind whenever you go to actually use the auto tie wizard and RIE process, that you need to make sure this document's up to date. And if you do go open that notepad, you'll notice there is instructions that goes through what the actual measurements in this document mean. It's very easy to quickly change and re-import that into your RIE process. So here I've set up what I'm going to call my 3 key factors for success. These are 3 things we must have to actually have our targets auto-detected in the software. So we're going to kind of go through each one of these points and kind of break them down and what we're looking for and things to avoid. So number 1 is target reflection. Obviously, majority of the targets, either if you guys are peeling them or if you're painting them, you're going to need a good high reflectance paint or sticker, because you're going to need a contrast surrounding areas to be able for the software to find it. The other thing is point distribution. The software needs a minimum of 10 scan lines, where each scan line contains 10 points. If we do not have that minimum number here, the software will not find your target. And number 3 is one that I see a lot of people do not take into consideration, but it's the actual target orientation itself. So the big one there being that the scan lines can actually not be parallel to the direction of the trajectory. So that's a big one to think about, and we'll get a little more deeper into that. So going through, number 1 is going to be target reflection. So like I said earlier, target reflection must contrast the surrounding environment. If you have an area of high reflectance, you're not going to be able to put a high reflectance target there and there being enough variation in the landscape for the auto detect to actually find the target. So that's number 1. Number 2 is low variance in the target reflection. And the number 1 thing I see here is that making sure that there's not cracks either in the paint or somehow in the sticker itself. Those cracks are going to cause variation in the target's reflection, and the auto finder is going to look for that same reflection all the way throughout the target. So having that variance, like a crack in a target, is not going to work very well. And the third thing to keep in mind here is to keep targets away from similar reflectance. Big thing, as everyone here knows, when you're out on the road, a majority of traffic road markings are marked with highly reflective paint. So you're going to want to keep your targets far enough away from those items so that the software doesn't get confused on, let's say, a strip versus an actual target. So we're looking for a minimum distance of about 2 meters in between those objects. So when you're out setting your targets, that needs to be in the mind. And the other thing here is I've actually laid a really good example of what not to do is don't actually place your targets next to each other. This is an actual example we had on a project where there was 2 rectangle targets placed right next to each other. So that, of course, is a practice you're going to want to avoid if you're trying to use auto detect. Number 2 is point distribution. This is a big one. If we don't reach that 10 line and 10 point minimum on the targets, the auto pick will never pick it up. So when we talk about point distribution, we're really talking about 4 key factors that go into the correct point distribution that you need to think of when you're actually out driving. So number 1 will be pulse rate. Whether you have a higher dense scanner or a lower dense scanner, you need to be knowing what pulse rate, whether it be 1.8 megahertz, 1.2, or a 500 kilohertz, that you're actually collecting at to know that you're going to get enough points on that target. What also plays into that is vehicle speed. Obviously, if you're driving faster, you're probably going to need a higher pulse rate or a larger target size to actually get enough points on that target. If you're driving slower, it's not going to be as much of a problem. The third thing really to think about is target size. The larger target, you're going to have more points on. The smaller target, you're not going to get as good distribution of points actually on the target itself. So that's another thing to keep in mind. And the big thing here is target distance. Obviously, the further away your target is, the more unlikely it will be that as many points are going to be hitting it. So as you go further and further away from either the highway or the interstate or wherever your scanner is placed from your trajectory, that target distance is really going to matter. There's a couple things we can do kind of pre-collect to actually plan these things out. So all these factors can actually be placed in RiAcquire, and you can actually see those values and see what points you're going to be hitting per square meter estimate. I will let everyone know we also do have kind of a beta version of the MLS calculator you can install that kind of does the math and visually shows the point distribution for you. Because it's in beta version, we don't have it out to the public yet. So if that's something that you guys are interested in at least looking at, you can email me, and I can send you over an install for you to test out on your next collect, because I'm also curious to see how it works live. And the third thing, and the thing probably not thought about the most, is the actual orientation. So for discs and rectangles, the orientation really doesn't matter as much, but for checkerboards and chevrons, which is actually per our poll the most used targets, we need to really think about the orientation if we're wanting to do an auto detect. So the big thing here is that in RiProcess, it's not going to find a target if any of our scan lines are actually parallel to the target lines. So here I've actually shown an example of a perfect orientation for a checkerboard when ran with the auto find detect. As you see here, it's getting a perfect cross point pattern on this checkerboard perfectly. So let's go on to the next example of chevrons. So if you look here, we have unfavorable orientations and favorable orientations. So if you look at the two unfavorable, the big thing that's stopping us here is we have parallel lines that are hitting our target, as you see here, and then we have them running on these bottom sides as well here. If in the field, these chevrons were placed this way, imagining our trajectory going here, kind of south-north on the PowerPoint, they actually wouldn't be picked up. They could be, just the odds would be very less likely, because we're looking for this perpendicular on the scan pattern versus this parallel. So if you're having chevrons and you've had trouble getting RiProcess to actually pick them up, this is one thing you're going to want to look at, is how you're actually placing the chevrons down on the ground. So this is the favorable, this is the unfavorable. If you guys go to the handout in the GoToWebinar, you'll find a PDF that actually completely breaks down all this information for you, and as well as more information on how the actual auto tie works. So I would suggest anyone who is interested in using this actually go download that and test it out and see how they like it. So next, I want to get more into the project management idea, kind of getting away from the planning, going more into on the actual management side. And we have a really good free tool that I want to introduce you guys to if you guys haven't already seen it or use it, called RiMAP. So kind of the first big question is, what is RiMAP? RiMAP is a free ArcGIS Pro add-in for cataloging all of your LiDAR collects. It currently works with our airborne, our UAV, and our mobile data set. So basically everything RiProcess handles, anything in the Kinematic world. And I can tell you, in the same database, you can have multiple of the same projects. You can have airborne with UAV with mobile. So if you're using several different systems and several different types, it's okay. The current version of RiMAP only supports our metadata and our trajectories, which actually shows our trajectory information and our actual LiDAR collects, but it does not show imagery or LiDAR. Those two things are coming in future versions. They just are taking a little bit longer to figure out. So they'll be available kind of in the future. So let's first take a look about what RiMAP does. So the first kind of step into introducing RiMAP into your workflow is to actually import your RPP file into ArcPro. And as you see, once you import that RPP, you'll actually see your trajectory and your LiDAR coverage live in ArcMap without having to really do any like crazy imports of LAS files or any other line data. As shown here, one of the kind of the coolest features, especially if you're kind of a statistics person, is you're going to have live view attribute tables on that data ready once you've actually went in and placed these RPP files in. So without ever having to go through and actually publishing anything, this is just going to very quickly give you a attribute table of the statistics on your collect, either on the trajectory or the LiDAR coverage itself. So there's a lot of great information in there. For example, how far you actually collected, how fast you were driving, what's the extent, what's the coordinates, all that great information will be all imported direct very quickly to a attribute table for you. The best feature, and really the reason why RiMAP exists, is of course publishing to Arc Online. If you guys are not familiar with Arc Online, it's ArcGIS has a really good online portal for you to actually create web apps to show and use your data with. So this menu here gives you a very quick dashboard for creating and importing projects into your ArcGIS online database. So what you would do from the beginning is, go take all your LiDAR collects, create a geodatabase using this tool, publish it. Then as you do more collects, you will slowly add more and more of those RPP files into the geodatabase and at live updates, so you can kind of keep things up to date. Once you've actually published all your projects, you can actually use some of our pre-made dashboards, or you can create your own. So if you have someone in your office who's an ArcGIS online wizard, they're going to be able to take that data and make any custom dashboard that you want. But for those users who don't have that experience, we do have 3 pre-made dashboards that I'm going to show off real quick. So the first, we're going to play a quick video. We're going to play a quick video of our first dashboard called our RiMAP project dashboard. So as you can see here, this is a pre-made dashboard. There was no work. This is automatically done. We have a map that has all of that information already loaded onto it. In the left-hand side, if we kind of work left to right here, we have all of our available projects as in that database in the viewer. So there we can see I have 4 different collects there. And we can have a bunch of different information on there as far as summary of the actual operating sensor. So you can actually tell how many hours are on each of the scan heads just by having this in there. That's going to be really great for those when it comes time for system maintenance. As well, you can see is the actual scan time itself, and as well as the average altitude per record. Then on the side, you'll see on the right, we'll have more quick statistics on each collect. So you'll see we have their actual mileage of the collect. We'll have the actual speed of the collect. We'll have the percentage of the operated. We'll have our average coverage. So you'll see me here. Actually, now I'm navigating to, I believe, Texas. You'll see me zoom into a new project, and we'll see over here in this right-hand menu a completely new set of statistics. So for example, in this collect, I was driving 19 miles an hour, 5% scan coverage, and 35 miles total driven. So that is a quick look at the project dashboard. I'm not going to let that video play all couple minutes. So we'll go next to our next dashboard that can auto be created, and that is our searcher application. So the searcher application is going to allow you to see those live statistics like we saw on ArcMap with the attribute tables kind of live in this software. And we'll go ahead and hit play here and get it going. And you'll see here, what I'll do is I'll hit this search bar and I'll pick one of my projects out. I'll hit search and it will automatically find me that project based on the name. That's not the only way to search for projects. We can set up different parameters in the search in case you didn't know the name of the project to actually go and find it. Once we have that project found, we're actually able to click on some of that information in the web browser, and as you see, it automatically popped up an attribute table. So all those nice live statistics we were able to view earlier on in ArcGIS can now be viewed here. Why is it so much more important for it to be able to view here? That's because you're going to be able to take this link and actually share it out to the masses around your company. So when it actually comes to sharing statistic information on LiDAR collects, it's going to be much easier to send this link to one of your colleagues or your customers rather than have to send them data over. So if they need any information from here, they can quickly get it from ArcMap online instead of actually having to go dig around themselves. And we'll pause that and move on. And the third one has more to do with actual project managing itself. This one I don't have a video of, so I'm just going to kind of go through each of these windows itself. So this is actually called the project status dashboard. And what it's supposed to show is actual live processing progress made by your employees. So as we'll see here, I pulled in one of the projects that I have in my database. And as you see here, there's a bunch of different statistics on the actual processing status itself. So you'll see here is it RBD classified. So how much percentage of this point cloud has actually been classified? As you can see here, that's 100% no for this one. The RBD is colorized. How much of this data set has been colorized so far? As you can see right now, it's about 89% no, 11% yes. If you move up to the top left here, you'll see how many of our raw scans have actually been processed and registered into point cloud. You'll see right now we have total of 20 scans and total of 20 processed, meaning that we're 100% processed. And it also shows the same thing with the imagery. How many raw image files do I have, and how many finished image files do I have? So you can live see the progress of this project just by looking at these process scans and this image processing. We also have some more information down here on the individual scan records themselves. We have things that show if noise removal has been run or if classification's been done on which individual record. And the same thing kind of over bringing from the left hand over, how many of these records have actually been colorized. So this is going to be a really quick way for you guys to be able to actually see that information live here. We're going to get into now this new workflow that we have made here at RIEGL with merging TLS data, MLS data into RiProcess easily. So the first question you kind of have to ask when you're talking about this workflow is, why would I even want to do that in the first place? So first off, terrestrial scanners versus mobile scanners will always give you a greater detail on key features. So I'm thinking of things like buildings, under bridges, maybe if you didn't catch a certain section of a canopy that you need, or really just any kind of infrastructure. If you need greater resolution of that detail, a terrestrial scanner is going to be able to get you there, to where a kinematic scanner or mobile scanner is going to get you more of the long data. Let's say, for example, if you need a small amount of data post or mobile collect. So you go out, you take your mobile scanner, you go out, scan a bunch, you get back to the office, and you notice, man, I didn't get enough data points on this one key feature, or maybe this couple little areas we need a little more data. It's much more efficient and much more quicker if we just take our terrestrial scanner out there, because it's much smaller than a mobile scanner, go out there, place our tripod down, do a couple scan points to that area and come back to the office, than it would be to actually get out, set up a mobile system and go out there and collect it. So if you just need to fill in those gaps of your mobile scans, a terrestrial scanner is going to be really good for that. And kind of third is a terrestrial scanner is going to be able to get into a lot more areas that a mobile vehicle can't reach. I'm thinking about those underpasses of bridges where maybe you aren't going to be able to drive, or maybe it's a field you're not going to be able to get your vehicle out to, or it's a trail. There's just the mobility of a terrestrial scanner when you're carrying it. It's going to be a lot greater than where you can actually fit your vehicle. So sometimes they kind of fill in these needs where we need them to. So in RiProcess itself, we've actually set up a 5-step workflow that's going to be able to merge both your terrestrial and your mobile scans very quickly without little manual work on the end. So I'm just going to kind of go through those 5 steps with you guys, and we're going to look at some data afterwards. So wanted to first show off the 2 systems that we actually used for this test. So I collected some data back in May with our VMQ-1HA that you see here on the left. It was of a highway here in Winter Garden. We had 3 total passes on the highway with the VMQ. And then all the way in October of this year, we sent some people out with our VZ400i and actually went and collected a building next to that highway. So even though these scans were collected months apart, we had no problem actually merging the data together. So that's where it comes in, is the VZ is so much good at actually going out and getting those little areas that you need to collect. So let's talk about the workflow real quick. So if you get none of you are familiar with RiScan Pro, it's actually the processing software we use for the terrestrial side. So in RiScan Pro, there's actually an export option that allows you to straight export out to RiProcess. This will allow you to export out really quickly to RiProcess by just setting that up, and it will automatically give you a menu where you stick those files at. In RiProcess itself, we're going to open our RPP, open our project up, and what we're going to do is go in and create a new INS GPS and laser device for the terrestrial unit. So if you're used to this on the left-hand side here, if you're used to this menu in RiProcess itself, you'll see we went in, we've added a VZ400i, both in the laser devices and in the GPS unit. So so now you'll need to import, earlier when we exported to RiProcess that gave us these RXP files, you'll now need to go and import them into RiProcess itself. Pretty simple by just clicking on records and doing a new collect. And the last thing is we'll need to come and add a new trajectory. So when we did the export to RiProcess, RiScan Pro actually created a POF for us to use as a trajectory for RiProcess. So we need to go in and add that trajectory in. Once we have all of those stuff added in and we have our devices set up, we then go through and set up all of our scan records to those new devices. We then go through and add processing parameters. I would recommend using the same parameters as you would for a mobile collect. And once that's done, you're actually able to actually process the data. So before I actually get into the data, we're going to run another quick poll, as you guys should see on screen now. Just asking if anyone here has any experience merging TLS and MLS data before. So we actually have had some people here, so I'm glad to see that. I hope your workflow was easy as well, and actually merging that data together. And a lot of you are interested in the future, so that's good to hear. Because like I said, it can be a huge benefit to your workflow, just kind of having that safe net of having an idea of how to actually do it. So I'm going to move on now. We're actually going to take a look at some of the data that I did after I merged. So quickly here, this is just a quick 2D view of the actual mobile collect. So this is just the mobile collect itself. As you can see, we gathered a lot of great detail on the highway here, but the main area we're going to be focused on is these three corner buildings down here, because that's actually where the terrestrial scan took place. So moving on to actually having the data together, you can see we've got a lot more detail around these buildings here. So we had about, like I said before, about 9 scan positions set up around this building to gather those details. And as you see in the 2D viewer, they've now been merged. So taking a look even further, this is the 3D view of that same building with just the mobile scan data. As you can see, we just kind of hit the front of the building. We got a little bit behind maybe the side, maybe some points shooting through the windows, and we didn't catch almost any of that parking lot at all. But if we kind of look at both data sets merged together, you can now see we have a lot finer detail on that building structure as well as the parking lot itself. Then moving here, we got a quick little video I made just kind of giving us a 3D view of that building. So as you can see, the terrestrial scanner really did a great job of capturing all the details of that building, and it actually merged in pretty well with everything there. You can see everything's lining up really, really good. So like I said, that was done in a quick, easy 5 steps. So you could probably see the benefits of actually having a terrestrial unit, you know, even in case if you need more higher details on those areas. So before I move on, does anyone have questions about merging our terrestrial data and our mobile data? All right, cool. I'll move on. So that's really all we had today. So just wanted to give you guys a quick review of everything we covered. So when you're wanting to have your targets auto-detected, keep our 3 keys in mind. Keep your target reflectance in mind, keep the point distribution in mind, and keep the target orientation in mind, especially if you're using chevrons. It's really where you're going to see the most importance in keeping that orientation correct. So for RiMAP, make sure that you guys know that it is free if you already own ArcGIS. So if you already own ArcGIS, you might as well be taking advantage of the tool. And also, you know, it makes project metadata and trajectories as well easy to access for anyone, especially with those ArcGIS online dashboards. You're going to be able to just create dashboards and send them out to your clients or your, you know, enter the office. And of course, merging our TLS MLS data, it just takes 5 steps in the right process. Our collects can be done at different times, and those terrestrial units really can gather a lot higher detail in those desired areas. So yeah, that's all I had today. I thank you all for coming. We do have a question in the chat. It's, can RI precision adjust the mobile data to match the terrestrial data? And yes, it can. So if you ever pull in terrestrial data, you're going to be able to process it the same way you would any kinematic data. You can even go through and set type planes, and you're going to be able to actually either hold down the terrestrial data or hold down the mobile data, because especially if you guys know, if you had something going on with your base station or in general, terrestrial scanner is going to be more accurate. So if you wanted to make an adjustment to the terrestrial scanner, you could, and also vice versa. If you wanted to hold the mobile data to the terrestrial scan, you could do that as well in those areas. So yes, you can run right precision once the data's in there. And you can also use the scan data adjustment to manually do that if you wanted to instead. All right, well, if anyone does have any more questions, feel free to reach out to me. My email is on the screen right now if you guys had any more questions on any of this stuff. And make sure you download that handout if you're interested in using the Find Tile Object Wizard. It's going to be a really benefit for you guys to go through that. I thank everyone for coming to today's webinar, and I will speak to everyone later. Thank you. Bye.